Ready?
Today we'll be discussing and analyzing the topic of force and motion. Specifically, we'll be talking about the motion of an object in free fall, like that. One thing that we want to analyze are the different variables that affect the motion of an object in free fall. Without further ado, here's Cody.
The first variable we decided to test based on our focus question was the mass of an object. To test this, we asked the question, how does the mass of an object affect the acceleration of the object? To test this experiment, we have a book and a marble. What do you guys think will happen when I drop these together from the same height?
I think the book's going to fall faster.
Why?
Because the book is heavier.
Okay. Julian, what do you think?
Well, I think the marble is going to fall faster.
And why do you think that?
Because the book is larger and has a bigger surface area, I think the air will resist it.
Okay, well let's see what happens. I will now drop the book and the marble together from the same height, adding no external forces. It appears that they both hit the ground at the same exact time. Why do you think this happened, Chelsea?
So the force of gravity must be acting the same on both objects.
Do you agree with that, Julian?
Not so much. I think since the book is heavier than the marble, I think that the gravity acting on it is greater.
Well, actually, the reason that this happened is because in order for the larger object to fall at the same time as the smaller object, the net force acting on the larger object must be greater.
But because the heavier ball's mass is greater, it needs a larger force acting upon it to produce the same rate of change. The ratio of the net force to the mass of the two objects, the book and the marble, are the same for both objects. So they fall at the same rate. Thank you, Cody. Without further ado, here's Chelsea.
So the variable we are testing now is surface area. Our question is, how does surface area of an object affect the acceleration of the object? To test this, we have a book and a coffee filter. Okay, so if we drop these two from the same height with the coffee filter open, what's going to happen?
I think the book will hit the ground first because it's heavier than the coffee filter.
I think the same thing, but I think it's because the coffee filter's lighter.
Okay, let's see what happens.
We were right.
Yes, we were.
Okay, so I noticed that you said because the paper was lighter, that's why it fell slower.
Yeah.
But what happens if I crumple up the coffee filter? Is it the same weight?
Well, yeah, I guess.
Okay, well, let's see what happens now.
Huh, they fell at the same speed. They hit at the same time. So why did the paper that was opened up fall slower than the paper that was crumpled up?
So it's because air resistance is pushing up on the paper, resisting its motion. Since the paper has less gravitational force acting on it than the book, the upward air friction force affects acceleration due to gravity the greatest, causing the paper to accelerate slower than the book.
So class, now we're going to talk about our third testable question, which is how does the air resistance affect the acceleration of an object? So what's your claim? What do you think is going to happen?
I think the book is going to fall faster because it's heavier than the paper still.
Okay, so you think the book. Anyone else?
The book.
The book.
Based on past experiments.
Okay, let's see what happens.
And clearly the paper fell much slower.
Wow.
Interesting.
Okay, now we're going to put the paper on the top and see what happens. But what do you guys think is going to happen?
Well, I think the paper will just push up and will still fall slower than the book.
Yeah, I think the book will fall quicker and hit
Yeah.
the ground first.
Like it will fall and the paper will still just be
Yeah.
fluttering around,
Yeah.
for sure.
For sure the book.
Okay, let's see.
Interesting.
Huh. Now, what would happen, do you think, if you put the paper under the book?
Let's test it out. All right.
I think.
What do you guys think is going to happen?
I think the book will force the paper down.
Yeah,
Yeah.
Think we'll force the paper down?
definitely.
Let's try it out.
Whoa.
Ooh.
So in both instances, when the paper was on top or on bottom of the book, it fell at the same rate the book fell.
Right.
But when it wasn't with the book, it fell much slower. It fluttered.
The reason the paper fell slower the first time is because air resistance was pushing up on the paper, resisting its motion. Since the paper has less gravitational force acting on it than the book, the upward air friction force affects the acceleration due to gravity the greatest, causing the paper to accelerate slower than the book. Now, in the second and third experiments, the air resistance of the paper is blocked by the book. The piece of paper on or under the book acts the same as all the pieces of the paper inside the book. They fall at the same rate and act as one object.
So having done all 3 experiments, we've learned quite a few things, and here's a summary of what we have. Excuse me. Okay, so our first testable question, how does the mass of an object affect the acceleration object? We found that, in fact, the mass does not affect the acceleration of the object. While some students would have a misconception that it would affect it, it doesn't, because although mass acts as a resistance to the force of gravity pushing down on it, so more mass resists more of the gravity, more of a gravitational force is applied to it, so in all 2 objects of different mass will still fall at the same rate. So for our second testable question, we have, how does the surface area of an object affect the acceleration of the object? What that really means is, how does air resistance affect the acceleration object? And it does have quite a factor when we're dealing with the falling motion of an object. As we did, we had an open piece of paper and a crumpled piece of paper, and although they both have the same mass and same weight, the crumpled piece of paper fell at a faster rate than the open paper. That is because the air was able to push up on the open paper due to air resistance and the force of air resistance, which is a sort of a force of friction. And the testable question number 3 was very similar. How does air resistance affect the acceleration object? In this case, well, when we put the book underneath or above the paper, it still fell at the same rate as the book. Everything fell together, basically, and everything was acting as one object. Whereas when we had the paper by itself and the book by itself, the paper sort of fell and fluttered, just as we've seen in our previous experiments.